All right, this is the last part in this factoring quadratics series. I'm going to be talking about special factoring cases that are important to know. Okay, and to introduce them, we're going to start practicing some factoring problems to get to the special cases and to see the special cases. So for example, if we want to factor x squared plus 2x plus 1, we need two numbers that multiply to 1 and add to 2. What are those two numbers? Must be 1 and 1. Okay, so we can factor it as x plus 1 times x plus 1, which we can rewrite as x plus 1 quantity squared. Okay, let's move on to the next one, 1b. Very similar, x squared plus 4x plus 4. We want two numbers that multiply to 4 and add to 4. What are those two numbers? It's 2 and 2. So we can factor it as x plus 2, which is x plus 2 quantity squared. Okay. Hopefully you can probably guess what the special case of the factoring is. Let's do one more. X squared plus 20x plus 100. We want two numbers that multiply to 100 and add to 20. What are those two numbers? 10 and 10. So we factor it as x plus 10, which is x plus 10 quantity squared. Okay. So this is the special factoring case number 1. If we have this form, x squared plus 2a times x plus a squared, we can factor it as x plus a times x plus a, or we can rewrite it as x plus a squared like we did, okay? We need to be fluent in going both directions. So if we have this factored form, we should be able to expand it out quickly. If we have this expanded form, we should be able to factor it quickly, okay? We need to be able to go in both directions, okay? So for example, we have x squared plus 10x plus 25. Notice the big clue is this is a perfect square. 5 squared. Yeah? What's 5 plus 5? That's 10. Okay? So once you get the experience, you can already jump to that this is x plus 5 quantity squared. This middle step over here, I'm just showing my work of exactly why I explained. I noticed that 25 is 5 squared, and this 10 is 2 times 5. And then we can use this formula right here. Okay? And then I was saying we have to go the other way as well. So x plus 12 quantity squared. If once you get fluent, you should be able to do this quickly and jump directly to here as x squared plus 24x plus 144. Okay, to use the formula, this one, it would be x squared plus 2 times 12, a is 12. 2 times 12 times x plus 12 squared. Okay. All right, let's do more. Let's go over the special factoring case number 2 by some examples again. It's pretty much the same as this case number 1. What if it's x squared minus 2x plus 1? So we need two numbers that multiply to positive 1 and add to negative 2. What two numbers are those? Negative 1 and negative 1. So we can write as x minus 1 times x minus 1, which is x minus 1 quantity squared. Okay, one more quick example. X squared minus 14x plus 49. Two numbers that multiply to 49 and add to negative 14. What is that? What are those numbers? Minus 7 and minus 7. So we could write as x minus 7 quantity squared. Okay, so this is the special case number 2. It's just that if there's a minus sign here, it'll be x minus a times x minus a, which is x minus a quantity squared. Okay, this is actually the same as case number 1. It's just that instead of the plus a, you substitute it with a minus a. That's it. No difference. Okay? Let's even think about it. Let me go back to this one. Okay? So replace a with a negative number, like negative a. So you would get negative a right here, where my cursor is. So it'll become a minus 2ax. And then negative a in parentheses, all of it in parentheses, squared, is just a squared. So that's why I'm saying it's the same thing. Okay? You just replace the plus a with a minus a. And then when you simplify it, you get this. Okay? Anyway, two examples, x squared minus 16x plus 64. The big clue here is 64 is 8 squared, so maybe it's a perfect square. 8 squared, so we want the number 8. So what's 2 times 8? That's 16. Oh, look, works out. Here's the work to prove it. And then x minus 8 squared. Okay? And then we have to be able to go the other direction. So like x minus 11 squared is x squared minus 2 times minus 11. Oh, sorry, plus 2 times negative 11x. And see, notice how I'm doing it using the other formula, not this one. It's the exact same thing. Plus negative 11 squared is x squared minus 22x plus 121. Okay. All right. Notice that if you haven't noticed, figured it out, I should say. The reason these are special cases is just because it's one thing squared instead of two separate factors. It is two separate factors, but it's the same factor, so something squared. That's why it's a special case, okay? And here's special case number 3. What if we want to factor x squared minus 1, okay? What happened to the middle term? Why is there no like something x? It is there, but let's rewrite it as 0x, yeah? 0x is just 0, so that's why it's not there originally. It's a waste of space to write the 0x. Unnecessary information, so we usually don't write it, okay? But it's technically there, 0x minus 1. X squared plus 0x minus 1. So let's factor like normal. We want two numbers that multiply to negative 1 and add to 1. Sorry, add to 0. What two numbers are those? Negative 1 and 1. Okay? So it becomes x plus 1, x minus 1. Okay, let's do another example. X squared minus 9. Let's rewrite it as x squared plus 0x minus 9. So we want two numbers that multiply to negative 9 and add to 0, by the way. If they multiply to a negative number, that means one of them must be positive, one of them must be negative, yeah? And if they add to 0, then they must be of equal magnitude. Think about it. Equal magnitude. Notice the equal magnitude. 3 and negative 3, just opposite sign. Okay? So it's x plus 3, x minus 3 in factored form. One more, x squared minus 100. Let's rewrite it as x squared plus 0x minus 100. So we need two numbers that multiply to negative 100, and they add to 0. And one of them must be positive, one of them must be negative, because the product is negative, yeah? Since the sum is 0, they must be the same, just in one's positive, one's negative. And the two numbers, therefore, are negative 10 and 10. So we can write it as x plus 10, x minus 10. Okay, so this is special case number 3. If we have x squared minus a squared, it's x plus a, x minus a. We call this the difference of two squares because here's a square, here's a square. We're taking the difference, the minus. Okay, we need to be fluid and go in both directions as well. So from expanded to factored, factored to expanded. Okay, so if we have x squared minus 36, for example, that is, just to show my work, is x squared minus 6 squared. Okay, which is x plus 6, x minus 6 by the formula. And we went over the motions to get this formula in the previous examples, okay? If we have x minus 9 quantity squared, use the formula, that's x squared minus 9 squared, which is x squared minus 81, okay? Here's another example, x squared minus 3. 3 is just root 3 squared. So we can write it like this, actually. And then in factored form is x plus root 3, x minus root 3. So you can do it like this as well. It doesn't have to be nice integer numbers every single time inside this factored form. It could be radicals as well. All right. So in a nutshell, here are the 3 special cases you need to know. Okay. Hopefully this is helpful. This should be the end of this factoring series. These are typically the key concepts and topics that you need to know. All right, hopefully this is helpful. Please give this video a like if you found it helpful. If you're interested in more videos on more algebra topics, please leave a comment on what you'd like to see, and maybe I'll get to it if I get a chance.